Hello, this is the Group 12 presentation for vitamin E, also known as tocopherol and tocotrienol. I am David Flores, your speaker today, and I present this alongside Marcos Ahumada and Jessica Gonzalez. The IUPAC name for vitamin E, also known as tocopherol, is 2R2578 tetramethyl 2,4R8R 4A12 trimethyl tridecyl 3,4-dihydro-2H chromin 6ol. It's a large word for a large molecule. The molecular formula is C29H50O2. Also evidence you can see its length by the large amount of carbons on the molecule. Some of its characteristics include a melting point of 3 degrees Celsius, a boiling point of 200 to 220 degrees Celsius at 0.1 millimeters of mercury, and as it again is a large molecule, it has a molecular mass of 437 grams per mole. There are many different variants of vitamin E, such examples being the different kinds of tocotrienols and tocopherols. Moving on to the next slide, this is the general molecular structure of vitamin E. Groups, as demonstrated with the multiple methyl groups at R1, R2, and R3 of the arene ring, alongside its fatty acid tail, the tocopherols and tocotrienols demonstrate liquid solubility. The alcohol at the end of the arene ring helps to contribute to its high boiling point due to its hydrogen bond. And the history of vitamin E, the beginning of vitamin E as it's known now, began in 1922, where two scientists named Herbert M. Evans and Dr. Catherine Scott Bishop discovered it through the study of rats. During this time is when tocopherol got its proper name. It comes from the Greek word tokos, meaning birth, and pherein, to bear or carry. That is, to carry a pregnancy, with the ending ol signifying its status as a chemical alcohol. Through testing, they came to a discovery of an organic molecule that was necessary for the sexual reproduction elements of the rats. Such testing and research actually started prior to the findings of Dr. Evans and Dr. Bishop through the work of Dr. Henry A. Mattill and Dr. Conklin. They first interacted with it through the research of milk, investigating it to determine its properties as a perfect food. Vitamin E would then be isolated in 1935 and synthesized in 1938. And a year before that, 3 of the tocopherols, alpha, beta, and gamma, would be determined to be an antioxidant against lard. Vitamin E's synthesis is complex, deriving from 6-chrominol. There are 8 different stereoisomers. For example, A tocopherol is chemically processed by semisynthesis. Vegetable oils are isolated by a mixture of triple R tocopherols and converted to triple R alpha tocopherol by permethylation reactions. Permethylation is just any methylation reaction which very many or all possible sites are methylated. Only plants and other photosynthetic organisms can synthesize vitamin E. Those tocopherols and tocotrienols can be extracted and purified from vegetable oils and plant materials. Synthesis is promoted by enzymes to develop triple R tocopherols. Vitamin's primary mode of action is as an antioxidant. It reacts with unstable lipid radicals, stabilizing them into a stable vitamin E radical, which is then reduced back to vitamin E by either ascorbate or glutathione. Vitamin E levels in the body have also been shown to be related to myocardial infarctions or heart attacks. We're going to go more into depth with how it does do that with those heart attacks in the next slide, where we have a couple of case studies for you. In the first case study, cardiovascular and metabolic protection by vitamin E, a matter of treatment strategy, vitamin E has a large role in our bodily defenses, protecting us by breaking down lipid-soluble radical chains, protecting phospholipids in cell membranes, and plasma lipoproteins against peroxidation of polyunsaturated fats. Its defense against heart attacks comes here with patients decreasing vitamin E consumption having a drop of their blood plasma levels only 26% after only 48 hours. A low blood plasma level correlates with more heart attacks. There is also another case study, effects of vitamin E on the immune system and tumor growth during radiotherapy, which demonstrates how important vitamin E is to our immune system. The test in the case study was conducted with two groups of rats, one group with a carcinoma cell, vitamin E, and chemotherapy. The other group lacked vitamin E. The group with more vitamin E had more lymphocytes than the group without, as well as smaller tumors. These are the sources that we use to find all of our information. Thank you so much for watching.